Hello. We've discussed digital time-based correctors on a few of my previous videos. Typically these are used with an analog video recorder or in playback mode. It will take the video signal from the video recorder and write it to memory and then read that from memory out again, and that allows it to synchronize the timing of the video signal perfectly, removing any jitter, wobble and timing problems that can make it difficult to either capture or re-record that video. So they've been around for a long time, digital time-based correctors, and I've featured a few before. I've got some very large ones which I use with professional Schematic video recorders. I've also got this sort of thing, again a professional one. This is designed for connecting to almost any video source, be it composite video or S-video or YUV. As well as being a time-based corrector, it will also allow you to change television standards. So for example on this one it can take a PAL input and convert to something reasonably watchable as NTSC, and sometimes they can also do CCAM, and they can do them the other way around, and other sub-variants like NTSC 4.43. Some of these things will support. The trouble is, time-based correctors, they were notoriously expensive. Professional grade time-based correctors could cost thousands of pounds and were always out of the reach of sort of prosumers who wanted to be able to use them with camcorders and stuff like that. And of course people today want time-based correctors, especially for capturing. So typically you would put a signal through that and then capture on some device such as one of these or some other kind of capture device. Now some video recorders have a built-in time-based corrector, and that can be useful too, but a lot don't, and even if they do, it can be useful to have both an internal and external time-based corrector. So fortunately, back in around about the late 90s, it was possible to buy a sort of prosumer level digital time-based corrector. These were made by a company called GTH Electronics. It was called the ACE Converter box. And as well as a time-based corrector, it includes standards converter and what they call a proc amp, just like the professional ones, that allow you to change, for example, the color balance. And one key, very important feature, it can alter the relative position of chroma to luma, which is to say, because many video recorders, the picture is recorded separately, the picture and the luma and chroma is recorded separately. You can get a situation where the playback time, the chroma is dropped by a line. And if you have a second generation copy, it's dropped by 2 lines, and you can actually start to see the colour not lining up with the rest of the picture. So these can correct that. You can raise the colour back up again and also move it laterally, because that can be a problem too. Very often actually the chroma is out of phase with the brightness of the picture. Actually, this was a sort of Mark II version, the full time-based corrector. There was an earlier piece of kit from the same manufacturer, GTH Electronics. It looks almost identical, but it doesn't say converter. It's just advanced digital color and video enhancer. This does no time-based correction. So if you buy the PAL version of this, it only works with PAL, and they did an NTSC and a CCAM version as well. So though that's still useful, and it has some extra features as well, you've got some ability to trim the image, and it's quite useful. Very often at the very bottom of a VHS or beta recording there's a load of gash rubbish from the head switching point, and you can trim it off with this. So these could be useful too, but it is different sort of box. It includes the proc amp, but it doesn't include time-based corrector or converter from NTSC to PAL or vice versa. Looking very briefly at this, let's show you a little bit about how it works. There's a button labelled bypass, and when you press bypass it disables the controls for all the brightness and colour adjustments, but it doesn't disable the time-based corrector function. Here there are buttons for NTSC, PAL, or if you've got them both set in, CCAM, and they are used in conjunction with the frame rate and colour frequency here, which could be 4.43 or 3.58 megahertz. So for a PAL signal, you'd have that pressed in, you'd have that set to 50, and the color set to 4.43. For NTSC, typically, all of those would be the other way around. So 3.58 and 60 hertz and NTSC. And for CCAM, you'd have both of those pressed in. But the interesting thing is, if you've got both of them released, then the time-based corrector function is completely bypassed, and you only get the proc amp functionality. There's more information on the website for these, which is still live. Other features on here, you can fade, and it'll fade the picture and sound, because it has a sound audio loop through as well. It'll fade picture and sound together, which again was more useful in the days where you're recording onto tape than it is so much today when you're typically capturing video. And these particular units have been modified. They've got a firmware change in them which locks out the CCAM input signal. So normally the input is automatic. These are the output, but for input it's automatic. But in my case, in the default mode is that CCAM and NTSC 4.43 is locked out unless I specifically select it by pairing it up with a particular key sequence. And that's because CCAM could occasionally detect CCAM which wasn't really there, and you get a stripy sort of picture. So there's other features as well on this particular firmware, and you could order these with different firmware, or you can still change the firmware on them. Now, these are wonderful units, and it would be great, wouldn't it, if I could tell you a bit more about them in some more detail. Well, let's meet Gordon Hathaway, who designed and built these GTH Electronics time-based correctors. So, hello Gordon, it's lovely to put a face to the name after all this time. We've emailed many times before about these standards converters, haven't we? Yes. So I gather that I have the biggest collection in the world, is that right? I have 10 of the converters.
I'm pretty sure you're, yes, yeah, I'm pretty sure you have, yes.
People sometimes say to me, oh, would you like to sell one? And the answer is always a resounding no. And did you see one came up on eBay the other day for, it sold for about £460 or something silly.
Did it? I didn't see the final price.
Yeah,
wow.
Yeah, which is must make you a bit sad because they're now selling for like twice what you sold them for.
Well, the irony of that is I mean, we'll come back into this later, but I actually have one potentially for sale that I would have sold for $350. So he paid a lot.
Oh, okay, all right. So can I ask you, what was your background in electronics, and what inspired you to make the first unit, the version here, which
yes.
Does not have the standards converter?
Fine, okay. Well, like a lot of us, I mean, I dabbled in electronics all my life. I mean, my early teens, I built crystal sets, and my father helped me build a one-valve radio designed by the BBC. And at school, I joined the amateur radio club and played with the first Mullard transistors. But then I went and did a physics degree. I joined Baird TV, worked on color TV decoder, color decoder design, and then they got taken over. So a group of us moved to work for Decca in a lab nearby, which we set up, because they wanted something like the Baird design. And I was given sole responsibility for the color decoder. Having got that into production, I then changed tack and moved to Rankleek Wharfdale.
Sorry, I'm just so excited by that. So did you have anything to do with what, the Decca Bradford maybe?
Well, I was working, I didn't do the original design of the color decoder, but I certainly looked after it when the original designer left.
Right.
And I did a few of the improvements to it at that point. But I was designing an all transistor version that had some valves still.
Right.
And that never actually happened because Baird TV were taken over. But we moved to Decca, and I then produced the Decca Bradford chassis, which was based on the Baird design in a way. But I did a completely new decoder, and that was all.
I always thought it was fantastic, the Decca Bradford, because it had an IC and valves. It was a weird design like that, wasn't it?
Well, yes, all the time-based stuff was valve, because we didn't change that, because at that time doing transistor time bases still wasn't very good, wasn't very easy. I mean, although there were people who did.
BRC 2000 and stuff, yeah.
Yes, but we chose not to. But however, I did change the decoder to all transistor, and that worked very well.
Mm. Okay, yes. So you had a good career in television then, in what, the 70s?
Yes. Started in '66 with a physics degree and joined Bed TV. But then I think just for a career change, I moved into hi-fi and worked for Rankleaf Wharfdale, and that was okay until there's a bit of a downturn in the market. I ended up doing loudspeaker test equipment because they had a loudspeaker division which was still doing very well. And then I moved with another person to Roland Celestial in Ipswich, which is where I ended up in East Anglia. And my role there was to put their hi-fi electronics design, which was a new one, into production. But again, downturn in the market kept happening in the industry. And I ended up back designing test equipment for loudspeakers. And I was seen on Tomorrow's World showing our laser scanner, which would scan loudspeaker cones to show the breakup in the loudspeaker cone. So I did all the electronics to make the scanner do the scans and produce a nice image. So that was my job. But then I left Roland Celestial again. They moved. I mean, trouble with the hi-fi industry again was it kept on changing. But I was living near BT in Martlesham Heath, and I was taken on by BT Labs, where I designed video processing circuitry for a cable TV on-demand system, something which again never happened because the internet basically took over. But I learned a lot there, which helped me later. In fact, in 1995, because of my interest in video editing, I liked the idea of doing a time-based corrector. And at that point, I realized I could do it with analog circuitry, just using digital delays. It was quite a complex design, but it was manufactured under license by ACT Electronics in Cornwall.
Right.
And
I've not seen one of those. I mean, were they sold in decent? Were they sold in good volumes?
He made 100. He only made 100 of the time-based corrector. The trouble was it was complex to manufacture because it had lots and lots of small components, resistors, capacitors, inductors, and so on. And we needed to go digital. Funnily enough, despite the fact it was a time-based corrector, the prized feature was the color shift, because that one did vertical and horizontal color shift. So we agreed that I should design for ACT their DV2, which was in some ways the forerunner of the ACE. And when the wipes were added, the DV3 was looking much more like the original ACE, but still didn't have all the features that I put on the ACE. The next stage would have been a DV4, but the problem was that Andy Talbot of ACT wanted to put things on one by one, and he wanted sort of an incremental approach, where I thought, why not just put everything that we can do onto it in one go? But then everything changed because in 1997, for his own personal reasons, he gave up manufacture completely. So I was stuck. I was about to leave BT. In fact, I left in 1996, took an early retirement. So I thought, well, there's no option now. I've got to make this myself. So I made the DV4 basically as the original ACE.
Right.
And
that's this one.
That's the one you've got there. And originally without the vertical shift, but then I added the vertical shift in.
Right. Does this one have vertical shift?
You can tell on the left. You can tell on the, let's just see, it's the, if you go on the center row, it's about the third button across, which either says in...
it says, going across the center row, it's got video and then color, invert video, invert color.
No, that's without the vertical shift then. The one with the vertical shift had all the video inverts on one button and the vertical shift on the other button.
Right.
So that was the only apparent difference between the two, although actually internally they did use some different chips.
Right. So now the great thing about the vertical shift, of course, in case people don't know, is that a lot of video formats like VHS and Beta, every time you make a copy, the chroma drops by one line, doesn't it?
Yes.
So if you're down to a third generation copy, even if it's good quality, say it's Super VHS, you can distinctly see that the chroma has dropped.
Yes.
So that's why you on the later models, you'd press the button so many times and the chroma would go up that many lines.
Yes.
Up to a maximum of several, because beyond a certain point, it's hopeless anyway.
I think in total it's 3 lines, but actually there's a 1-line permanent shift because there are decoders in the ACE itself. So there's 1 line which compensates for the ACE's own drops. And then there are 2 more lines you can have. So it goes 0, 1, 2, but actually that's actually 1, 2, 3 internally.
I don't know if every format does that. I mean, for example, Schematics probably doesn't, does it?
I don't think Schematics does. No, it is the
professional
decoding.
Right.
Yeah.
So should we have a quick look inside this one? Now, this means going
Yes.
into battle with the case. Now, these cases, where did you get these cases from? It's just like a RS or Farnell type case.
It was a standard case. Yes, Vero Electronics.
Oh, right.
Yeah.
And
no longer made, sadly, but yes.
Oh, right. You
There's
push
tongue,
on the
a tongue
sides
groove.
and find whichever bit goes down, and then wedge something in there and pull it out.
I tend to use a flat bladed knife.
I have a spudger.
Yeah. Yeah,
then,
it is a, yeah.
There we go. And then once you've done one, you can wiggle the other. Yeah, it's the first time you do that, you're just terrified you're going to break something.
Yes, but no, it does come apart. Yeah. Same again. You're going to do the same again.
But this time, the top.
The other way.
Yeah. There we go. Yeah, the first time it's absolutely terrible. Yeah. So, how long since you last looked inside one of these?
I haven't looked inside of one of those for quite a few years. Yes.
Yeah. So lots of Xilinx chips and a Philips chip.
Yes, that's right. And those are all plug-in chips on that one.
Right.
Yeah. And yeah, the Xilinx, yes, one of the problems with Xilinx was they eventually went surface mount only, which is one of the reasons why the converter became a problem.
Right.
But yes, it was very nice. Those are all push plug-in chips, very nice and easy to make.
Right. So we've got there's also a Philips DIL chip,
yes.
a DIP chip, which is marked V7 on this.
Yeah, so that's the microprocessor. Yes.
Right, that's the processor. That's your firmware version then.
Yes, and there's a tiny little chip next to the Xilinx, which is the programming chip for that.
Oh yes, yes.
Yeah, there's an 8-pin one. Yeah.
Right.
Yeah, those were lovely and easy to make. No surface mount. Everything went in nicely. Then I had to change. The second version did have some surface mount chips.
Oh, the second version of this. So how many did you make of this early?
100 of the first one. And then I've forgotten the number, several hundred of the second, but that one only made 100 before I decided that there were new Philips chips coming out, and I could also add the vertical color shift. So,
and that was, of course, an important feature. So it was worth making putting all the engineering work into doing that.
Yes.
Do you know what price these sold for?
Well, they were always $249.95 for the original lathe, both versions.
Okay, I'll put that back together again later. So what inspired you then to move on from the Mark I to the version which is a proper time-based corrector? Right.
Well, I suppose it went back to my original idea of doing a time-based corrector, which I did for ACT, but as I say, was mainly analog and really far too complex. What happened was I became aware of the fact there were full frame memories on the market, and thought, well, yes, obviously I need to put some full frame memories in there. And the question is, what else do I need to do? And I was out walking one day and it just dawned on me how to do it all. And I got back and did work on the Xilinx chip, which had to do all the control, did a new PCB. And I was very fortunate that basically the hardware worked first time. So all that was fine. There were some interesting twists with the original design of the software and firmware, because there was a neighbor, I actually borrowed an NTSC tape from a couple next door who'd come from Australia, I think. And their daughter came in and she was quite amused to see this tape I was playing, because the colors were all wrong. Because it took me quite a while to get everything synchronized properly so that I didn't get the Y and the U and V crossed over. So this brown fox was blue, which he found most amusing.
Let's have a look inside. So now there was more than one version of this as well, wasn't there?
Well, that went through a few iterations in terms of the chips, but performance-wise, they were always identical.
Right. But you can't mix up the firmware from one to another.
No. Well, what happened was Philips actually upgraded their chips, and so the new ones became the dominant ones and became cheaper and more readily available. So I virtually had to change the input and output video chip. And yes, one of those requires a firmware difference, but everything else is the same. So in the software, I just do a switch and it does one version or the other.
Right. So which one is this? Can you tell?
Difficult. You have to see whether it's an SAA 7114 or 5, I think it is, isn't it, on the input?
And
The difference is quite honestly.
The reason, of course, people need to know what version they've got is if they ask you for particular firmware, we need to know which chipset they've got.
Yes, well, on certainly all the later ones, there was a date written on the PCB on the top of a production date, so I knew which one. But also, you could look on the chip itself,
Right.
and the letter on the chip itself tells me which version it is. So
right.
from that,
on the firmware chip.
Actually, on the firmware chip itself, it either says A, B, C, D, E, F, G, H, I, J. I think was about the final one.
Can't read it.
Well, otherwise, you look at the chip underneath on the bottom of the board, and you look and see which is the input chip.
The Philips one here.
Yes, it's one of those two Philips ones. It's not the 7129. It's the other one, which is either 7114 or 7115.
Right. This is 7115HL.
Yeah, well, that's the last one then.
Right.
Yeah, that's the first. That's the final one.
Right. And I've already had.
So now I know which software you would need for that.
Right. And in fact, I've already had a firmware change on this because you can put the stickers on there. And the firmware that I select, is it letter? It's E. I've got a feeling it's E.
Yes.
Because by default it will completely auto detect the input color signal.
Yes.
But I was finding, and I'm sure the customers must, that if you have a very glitchy tape, it will accidentally go into CCAM mode and you get stripy color, and it can be hard to get out of that position. So now, if you know what you're doing, when you switch it on, you press the color shift button, and it defaults to, it then switches to ignoring CCAM and NTSC 4.43, I think.
Yes.
But I prefer it to default to that situation, because switch it on and not worry about dropping into CCAM by accident. So if I want to use NTSC 4.43 or CCAM, then I have to power on with the shift up, color shift button pressed. Yeah,
to reverse that. Yes.
So the other features that come with that firmware is the freeze frame, which I have used very occasionally, and 3200K, which I believe is because people had a habit of leaving their camera set to indoor setting whilst outdoor and finish it with an extremely blue picture. And that would attempt to just correct it back in one go. I think that's what that was for.
Well, I'll tell you what happened. I mean, over the years, basically, one by one, lots of extra features were added. I mean, I know you queried why I had the digitized control, which in a way was a bit of a useless control.
Right, yes, that control there.
But I was very fortunate that I had a spare knob, because, of course, that became the zoom control. It did all sorts of clever tricks like that. But the other thing is that apart from all those sort of extras, which became added one by one, there was a special version done for the film industry. In fact, what you're getting there is a benefit from that, because the ACE 24 converts 25 frames a second normal video to 24 frames a second, so you can film it with a standard film camera without any flicker. In fact, that was used on some of the James Bond films for the video, to make sure the video didn't flicker. And at the same time, they wanted a color correction to change daylight to indoor lighting, which is why the 3200K was done for them. And the freeze frame was also done for them, so they could put a frozen picture up if they wanted. So a lot of those extras were all originally generated for the film industry.
Right. Well, I found the 3200K one handy, because I run an extremely obscure format called CVC. And those cameras were prone to getting into the wrong setting, and you finish up with brilliant blue pictures. Hit that button, and you get something approaching watchable anyway. It's not perfect, but it's a good one.
It's just an approximation, yes.
Yeah. Now, one thing which I might argue is a small weakness of these, and I know you've explained this to me, and I still don't grasp it, is when we're running from PAL to PAL mode, so we've got a PAL input and a PAL output, you apparently lose a little bit of vertical resolution. Could you explain that to me, please?
Right. Well, you only lose resolution if you've got the PAL button pressed in, and it's therefore, in effect, thinks it's doing a standards conversion. Well, doing time-based
corrector is in operation.
Yes. If you've got all the buttons out, then there is no loss. Right. The problem came with the full frame memories. They store, as I say, a full frame, 2 fields. And originally, I did nothing to control that. So if your input and output drifted apart by 2 fields, then you simply got a repeat of a field, well, for full frame, and the memories rolled round. And that appeared to work fine. When I tested it, I couldn't see a problem. But unfortunately, one of the people who bought a unit spotted a glitch when that happened. And it only happens every few minutes, but he saw a flash on the screen, and that clearly was unacceptable. So I had to take control of the rollover when you exceeded the difference that the frame memories could cope with. And the only way to do that was to sense when there was a 1 field shift and then reverse fields. The problem with the reversing field is you would end up with the funny jagged edges and funny effects on verticals. So this does get slightly complicated, but what I had to do was, when you start, everything's fine. Even field goes to even field, odd field to odd field, no problem at all. But when you reverse it, the fields being swapped over would in fact swap the lines over on the screen, which looks messy. So what I had to do then was to actually convert from odd to even and even to odd field. Now you can do that by interpolating and taking adjacent lines and averaging them, which gives you a half line shift. So you can actually correct that with a half line shift. Or if you do it on every field, you have to use a quarter line shift. Basically, when the input and output are in sync, there is a drop. It shifts a quarter line one way. When they're out of sync, it swaps the fields over and there's a quarter line the other way. Very difficult without drawing diagrams to explain that. But the downside, well, the downside and the upside, the downside is you're taking a quarter of one line and 3/4 of another line and averaging those together. And that gives you a very small reduction in vertical definition, but it gives you an improvement in noise. So since VHS has anyway a very poor horizontal resolution, slight loss in vertical resolution I didn't consider too serious, but the noise reduction was an advantage. So it's a trade-off, but it's a trade-off to get around a problem which I found in the frame memories, which just would not cope with rolling around 2 fields. But there is another benefit. The original one meant that it jumped 2 fields every few minutes when it slipped that far. So there was more of a judder. When I converted it to the new system, it only moved 1 field. So you get a 1 field jump twice as often, but it's less of an obvious jump. So, and anyway, any time-based corrector has to cope with this. Basically, when the input and output slip, you have to either repeat or drop a field. So making it a 1 field drop and add was better than 2. It saved the glitch, slight loss of vertical resolution, slight improvement in noise. So compromise, yes, I agree. But
so you think
no
any time-based corrector, and I've got another one here, this sort of thing,
they all have to do something.
Done the same thing.
Well, they all have to do something when fields have to be lost or gained.
Right.
You either, yeah. The only other way around it is if your output rate is actually locked to the input rate and the time-based correction is sort of an elastic one in which you never restabilize totally. But I chose to have the output time-based running completely independent of the input. And then you do lose or gain frames as the two slip apart.
Now, another reason I mentioned this is because there is a feature of this which is definitely superior to this one. Mind you, I mean, how much did this cost? You know, we don't know, but a lot. But
yes,
when
10
I
times
used,
as much.
sorry, 10 times,
10
yes,
times as much.
Probably, yeah. When this is used for NTSC to PAL or PAL to NTSC, the results are much smoother than they are with this. So this is just doing frame dropping or frame repetition, isn't it, to solve the difference in frame rates. So this presumably has got some sort of interpolation in there. Heaven knows how it does that.
Yes, you can do more complex things, yes.
And
definitely.
that will be why this costs so much.
Yes.
That'd be the
Indeed.
fundamental thing that adds the cost to this. Yeah.
Yes.
Did you ever
Yes.
consider having a go at doing something like that?
Well, it's a totally different ballgame. I mean, I was in the consumer market and I was used to that. And yes, you end up having to produce something which is literally 10 times the price.
Yeah.
And then your market is very small and there are other people in the market already. So
right.
It's more of a gamble, basically.
And the other feature I always wanted, on these, instead of the digitized, but again, probably wasn't possible, but you can tell me why, you've mentioned there's a noise reduction as a result of the work you did there.
Yes.
But something like that, you have the option of adjusting luma or chroma noise reduction, and it gathers, I think, a number of fields and averages them out. Was there any possibility of that, or would that have required more memory than this had?
Yes, that would have been difficult. Yes, yeah. I think the way the memories worked, they were basically serial memories. Sort of what went in came out later, and to do the averaging would have been much more difficult. Yes, I did think about it, but it just wasn't ever worthwhile.
Yeah. I mean, after all, it's a consumer product, but it's a very good consumer product, I think prosumer is the phrase, isn't it? Because after all, the sort of people who bought this back in the day were the ones who were doing some fairly serious editing. They were recording something for the local amateur dramatics group or something, and it was, they need to get it right. So it gave them that option where there were no other options. Of course, some machines still do have built-in digital time-based correctors. Some Super VHS and high 8 decks and professional equipment like Betacam has built-in time-based correctors. But the thing I found these particularly useful for is if we look at something like Super VHS, you'll get a nice Panasonic Super VHS machine with a time-based corrector, and you can switch it on and off, and you'll see lateral wobble pretty much disappear when you select time-based corrector.
Yes.
But if there's vertical jitter, it doesn't do a thing for it. These are great for vertical jitter. They're very, very good at rebuilding the vertical.
Well, the reason for that is that all those built-in time-based correctors are only buffers which have a sort of a line or two lengths. They're only very short buffers. They don't use field buffers.
I'm not sure that's true of all of them. It certainly was true of some of the early Panasonic ones.
SVHS and things like that, certainly, they're very simple. So they don't have the possibility of doing anything more than just getting rid of horizontal wobbles. Right.
I believe there's a Sony machine called the EVS 9000, high 8 deck, which costs almost £2,000. And that's full frame.
That's full frame, yes. Yeah, I guess as time went on, that did happen, yes.
Yeah. I think that might have been true of the later Panasonic SVHS too. But still, they're not very good at vertical jitter, and that's what these are good at. So I tend, and there's a risk of this, and we'll talk about this in a minute, I tend to have something like a Panasonic SVHS machine with its time-based corrector on, feeding via S-Video. There's the S-Video there. There. I feed into there and then out of here into my capture device. Something like that. I think we've seen these things. But there's a hazard there because I've got two time-based correctors in series, and each one will add a video delay, won't it?
Yes.
So presumably there's a video delay in here of what? How many fields?
Now it is just basically one field. Yeah.
Right. So of course you won't see that. But if you've got two of them, actually you still won't see it. But if there's a lot of them, you can start to pile up, can't you?
Well, this coming back to what we said before about what I did with the getting rid of the way that the frame memory worked, because in the original design it would have had it could be two fields out.
Okay.
And where now it can only be about one field out. So actually even that became better. So time delay is ultimately important if it adds up, as you say.
Now, of course, you discontinued you more or less discontinued these in 2006, but I gather you made another batch later. Is that right?
Well, yes. I mean, 2006 was the final production, but 14 years later, I was approached by a National Archive company who wanted well, they wanted it with time-based correctors, but they actually wanted the vertical and horizontal color shift, so they could correct the obvious shifts we know about on VHS tapes and so on. They've got about 1 million tapes to digitize, and there were some of them did need some corrections. So they wanted 4 built. I looked closely at what I had, and I realized I could, in theory, build up to 6. And then that really did use everything that I'd had. But even to do that meant buying some parts on the not second-hand market, but on the open market, because their bits were obsolete. So I bought obsolete parts that were people's had left over from production and so on. So by doing that, I could make 6. So I built their 4. Built 2 more as complete aces, one of which I sold to a poor guy who lost his in a house fire, who'd had a previous one of mine, lost it in a house fire, so he wanted a new one.
I'll bet, yes.
And I've got 1 more which I could sell. I didn't initially, but actually now I'm happy to sell it if somebody actually wants one. So
I can safely say that as a result of this video, that will be sold. But I have 10, so I'll stop there. And there's no prospect of ever getting any more of these built, is there?
No. Well, the
by yourself or anybody else?
No, the Vera cases are no longer available. The front and back panels were all tooled with my own tooling, and I don't have any more labels. I think I've got some more panels, but none of the labels. So I can't make anything that looks like an ace anymore. And I've even the potentiometers, which were OMEG ones, I think you can get them again, but not easily. So yeah, a lot of the parts now are just obsolete and impossible to replace, and particularly my own parts, I can't get anymore, obviously, without making new tooling.
That's a terrible shame, because as a result of people archiving like I do and others, there is now an increased demand for these. And if you built 100, you'd sell them, you know.
Well, there are enough out there, and I think if people keep buying them on eBay, I can give them all the latest software and so on, and I can still repair them, because now parts I know are still available.
Right.
So,
and I had one fail, didn't I? Do you remember that? Because I've forgotten the detail. It was one of the QFP chip parts, which at the time I wasn't able to solder. I probably could now. It was possibly that one. The problem was that it would freeze up, and I could still operate the controls and put the color bars on, but the input signal froze up. And you helped me hugely in diagnosing what the fault was. And so I ordered a chip and sent it to somewhere locally who had the surface mount capability, and swapped it over ever since.
Good.
Was that which chip was that? Do you remember?
I'd have to look at my records. I can't remember which one it was that you had that was a problem with.
SAA 7115 probably.
It probably was the input, I think. Yeah, almost certainly. Yes.
But in general, they're reliable.
Yes.
And it's because what's wonderful to see is very few electrolytic capacitors. And I've done another YouTube video where I feature one of the time-based correctors I have, which is particularly good for use with Schematics. It has dub inputs. Dub is an obscure Schematic non-standard signal, and it's terrifying because it's sprayed in capacitors, and it also has lots of tantalum capacitors in there, and lots of scary stuff. And if it breaks, the chances of ever getting it repaired are close to 0. Well, the great thing here is it's not very likely to fail, and if it does, there's a good chance of fixing it.
Well, yes. I mean, apart from the ones in the audio circuitry, all the rest of them are only decouplings, and quite honestly, there's more than you need in there. If half of them failed, it wouldn't make a difference.
Now, we mentioned the audio, of course. You'd say, why do you need audio in a time-based corrector? And it's just for the fade feature, isn't it?
That was the only reason for adding it, because the original ACT DV2 and 3 didn't have any audio fade. I think it was something that a reviewer queried at that point, actually. And so I thought, well, I will put it on the ACE. And so the ACE always had it, just purely because some reviewer once told me you ought to have an audio fade.
And you had a spare button, presumably, at that point.
Well, yes, that's right. Yes.
Yeah, so you press that and it fades the audio and video. Now, of course, for the archivist in us today, probably not the most useful feature, because you do that at post anyway.
Yes. Yes.
Tell you what feature I always would have loved, which could have been added, but it would just be more circuitry, is when you put up the color bars. It would be wonderful if it put a 1 kilohertz tone on the audio channel.
Yes. Yes, yes, I agree with you. Yes, I think with hindsight that could have been added. I suppose the microprocessor could have generated a square wave maybe, but to produce a sine wave wouldn't have been as easy. It would have meant another chip or two.
But if it's a fixed 1 kilohertz, it wouldn't have been that hard. You just capacitors.
Yeah, yes, you're right. Yeah, you can make a very simple oscillator. Yeah.
So could you just have a time machine and pop back and do that for me, please? I like that feature very much. Oh, well, tell you what we haven't done. We haven't shown the circuit diagram. You've got ACE 20 CCT and ACE 35. Is the 35 the time-based corrector one?
Yeah, yes.
Right, that's the one we're most interested in.
Oh, yes, the other one would have been the original ACE, yes. Yeah.
Right. So looking briefly at the schematics, we have the SAA 7115. So that's your input. You've got IC1 on that, there's a clue.
That digitizes the video input, yes, and produces separate YU and V.
And that's 10-bit, is it?
Well, it's a 10-bit converter, and I think it's 9. Yeah, no, I think it was. No, that's a 9-bit converter, I think. 9-bit, but it gives a full 8-bit conversion, basically.
Right.
Which is all that matters.
Well, the reason I mention it is, I mean, you can sometimes see 8-bit, can't you? For things like when you have a very gentle graduation between one color and another.
Right. Well,
basically see 8-bit.
Yeah. Yes. I mean, broadcast standard is 8-bit. So as long as you digitize to 8 bits, you certainly match the broadcast standard.
Okay.
But the original A to D in the original devices was only an 8-bit A to D, and it was digitizing everything, including the sync. So you weren't getting 8 bits over the video. But when they went to a 9-bit converter, you get a full 8 bits over the video.
Okay.
So it gives you the equivalent of a broadcast standard.
Okay. Then IC2 we have XCS10 Xilinx FPGA.
Yes.
That's where your secret stuff goes, isn't it? Is that where your
that bit actually, ironically, that bit isn't secret because you can copy its programming, but
don't tell everyone that.
But you have to know what to do with it. Right. But that basically takes all the inputs from the frame stores. It also controls the frame stores. That does all the logic. There's no other logic in the device, basically. So the video passes through that. It has multipliers built in there, which do the RGB control. To do RGB, it actually has to do gain control on the red, green, and blue, which is done by using multipliers. It has the ability to do the horizontal time delay to give you the horizontal color shift.
Right.
For vertical time delay, it changes the timing of the way the memories are read out. So yeah, everything is done in all the logic is done in that.
What about the controls? Do like the red, green, and blue controls and the saturation, color, and shift? Do they all talk to that?
Well, what they do, they go through the microprocessor has three A to D converters, which in fact all those switches and controls are read as an A to D converter there, because rather than simply as a logic.
I kind of already knew that, because the way you control it, you see when you're turning something, some of the controls jump in how they work. It's not like it's an analog control, is it? Well,
they're 8-bit digitized, which you wouldn't see, but some of them have to be stepped because some of the controls inevitably are stepped controls. Okay. And so yes, and that's all done in the microprocessor. Now that's the bit I do control. Right. So all the clever tricks ultimately are done in the microprocessor.
Right. We haven't come to that though. We're jumping ahead of ourselves. So. So IC2 then, well, that was your Xilinx FPGA, right?
Yes.
IC3 going along is a digital video encoder SAA 7129A on this.
Yes, that basically takes the video from digital and gives you an analog output.
Right.
And the RGB and an RGB, because there is RGB on the SCART.
Yes. I mean, I capture on S-video for this.
Yeah, S-video is fine.
Yeah, some people might do RGB. There's no YUV output option, is there?
You can switch the RGB to YUV. Yes.
Can you?
But the Y doesn't have sync. The Y doesn't have sync, so if you want Y with sync on, you have to take the Y from the S output and combine that with the U and V from the SCART, and that can be done.
Oh, right. Okay. How do you do that?
Well, I sold a lead which you can buy them anyway, which takes the S video and gives you two phonos from it.
Yes.
And one of the phonos is the Y and one is the C.
No, I mean to say, how do you configure it to Y, UV out?
You press one of the buttons on the front, and I can't remember which one.
We'll have to look at the instructions. Right. Okay.
Yes.
Marvelous. Okay. What other ICs we've got? We've got a smaller IC, which I can't even see the number of.
Along the top, you've got the frame memories, two doing Y and two doing U and V.
Right. You mean physically, or one on top of the IC? Oh, at the top of the board. They're memories.
They're long, thin ones. Physically, they're long, thin ones.
Zips. Right.
They're zips. Yes.
Okay. Oh, right. I never really thought of them as being memories. Okay. Right.
There's the frame memories. There's
it's an odd package, isn't it?
Yes.
So there's a Philips IC4 is a Philips one, 87 LPC something.
Yeah.
Right.
Yes. That's a
microprocessor. That's a microprocessor.
Yeah, that does all the control. It reads all the control, reads all the switches and knobs,
right,
and it determines what should happen and sets up all the right values in them, because it has to control the input and output chip. It has to control the Xilinx. There's a feed to the Xilinx, so that controls everything. It reads all the controls, controls everything in the system.
Right. So that's where your secret code is.
Exactly. That is definitely locked and cannot be copied. Yeah.
No, and also cannot be changed, can it? So once you've programmed one of those, if it's wrong, you can't reuse it. It's thrown away.
No, that was a pity, because in the original ACE, the chip I used was UV erasable.
Right.
So with those, yes, you make a mistake, you've got to throw it away.
Yes, because that happened once, I think. I asked for a certain combination of firmware, and you sent it to me, and it didn't work. And it was, there was a mistake in that one, and we had to do another one. So I'll send it back to you, so there's no point.
No,
no.
It.
Yeah, that's right. We have IC5, which is XC17510, I think that is, with data and clock inputs and outputs. The very small.
Yes, that's the one that programs the XC one. That programs the Xilinx XCS10.
Right, that's the little one that sits there. Right.
The 8-pin one is the programming one for the other. That reads it up on startup.
Right. We have DS1. Can't read number sideways.
That's the audio fader.
Oh, is that what? Ah, right. Okay.
That's the audio fader. Yeah, with a buffer into it or buffer out of it. Yeah.
Right. That's where I want my test signal put. Right.
Yes.
And I think that's most of it, isn't it? And then we have IC10, which is HC4051.
Yeah, there are 3 of those, because in total there are 24 control signals from the switches and knobs, all of which are read into 3 A to Ds.
Right.
So it basically cycles round, each of them cycles around 8 switches and knobs. In fact, if you look at the center row, and the pots, you'll work out that if you add up, if you ignore the main switch, the power switch, and the one the other end, the bypass switch, I think that one doesn't. Oh, I'm not sure about the bypass. There's a total of 16 controls on that center and top row.
Right.
Because there are 16 inputs to the 2. There are 2 of those HC chips on that little board. So you can't have any more. Yeah. I was just fortunate to be the right place at the right time and with the right interest to do this.
And you built a fantastic product here. So this version also was sold for £250. Is that right? Is it 200 or 200?
No, that sold for 300. There was just £50 extra. Well, the difference really was just the cost of the memories and a bit more complex testing and construction.
And I ordered one with the extra firmware. I think so. It's just over that. I think I probably paid for my first one.
Yeah. I charge a bit extra if I had to do a special one. Yes, that was all. Yeah.
But I mean, it's fantastic value for money.
Thank you.
It really is that you get a real time-based corrector with the proc amp and the color shift, all for sort of £300. It was world-beating. There was nothing else like it, was it? You had no competition, did you?
No, I mean, there were other people who had made various things like color correctors, and there were time-based correctors available, but nothing in that market that did everything in one go. So in one box.
Just a pity we couldn't make some more now. But,
well, yeah.
What was the volume made? How many do you think you made?
I think I'm somewhere around the 2,000 total of both models eventually, that sort of order.
Right.
But of course, if you include the AC, sorry?
By both models,
you mean yeah, of all three, it's about 2,000, I think it is. Yeah, give or take. I mean, yeah.
But most of those were the time-based. Most of those were time-based corrector ones. Right?
Yes, yes.
I think there's a bit of a hazard now that people can go bidding on eBay, recognize it, bid on it, and then get the first version, which isn't time-based corrector. No, I've messed up.
No, you do have to be very careful because they obviously look the same. But one says advanced color enhancer, one says advanced converter enhancer, yes. And it's the converter you want.
That's right.
I just kept it as ACE, and ACE seemed a nice acronym, so I kept it as ACE.
Though there are a few extra features of the first version. You can do that nice trimming of edges. I mean, at the bottom of VHS and Beta, there's always that garbage at the bottom.
Yes.
It's nice that you can trim that off. But nowadays, you do that at post anyway, wouldn't you? Do that once you capture it?
Yes, indeed.
And for power, they're very non-critical, aren't they? I mean, I think there's more than one mains adapter type, but in general, they just put out more or less anything because there's rectification and smoothing, I think, on here, isn't there?
There is. I mean, ideally, to avoid the internals getting the regulator getting a bit hot, you ideally shouldn't go too high in voltage. But yeah, so a 9-volt adapter is perfect. And certainly with the United States, because I had to be very careful about, well, I mean, fire risk is an issue anywhere. But I mean, with the litigation in the States, I had to put a very, very firm warning. And in fact, if you look on the website, there is a description of the power supply requirements. And you do have to watch that you meet those requirements to be safe. And I did test the internal wiring so that if you short everything out, it only takes a limited current. But obviously, if the power supply can generate 10 amps, then things can get very hot. So you have to make sure that it's protected by not having too excessive a power supply.
Right. But you'd be okay if you were using a switch mode power supply. I mean, these are linear, by the size of them.
Oh no, I recommend switch mode ones these days anyway, definitely.
Right. So they're filtered okay for if there's a bit of noise.
Oh yeah, there's no problem with filtering or noise. No. As I say, I mean, it was interesting the way things ended up because my original aim was to have things made under license. And while ACT Electronics were making them for me, it left me to do design work, and that was quite nice and straightforward. But things change, and you just have to go with the flow. So it gave me an interesting chance because it meant that I actually had to do all the tooling. I had to design, in fact, the SCART connector on the back, there was no punch to make that funny shaped hole. I had to actually measure it carefully, do a drawing, and have a punch made exactly to the right dimensions, and it fit perfectly, so I was pleased. So it gave me a chance not just to do the electronics design, but all the hardware. I mean, obviously the PCB layouts I did myself, and the front and back panel tooling and the labels. The only problem I had with the labels was that they were very good, but when you stuck them on, they could not be removed, which meant that you had to be absolutely correct with alignment first time, or lost the label, lost the panel basically. But I got that off to a fine art in the end. And surface mounting was also a bit of a struggle, and I must admit initially that worried me a bit. But I've done it even a couple of years ago. I did it again, and I've still got all the kit to do it. So if necessary, I can do surface mounting. Still, so my eyesight's still okay for that.
Oh, I've got a microscope.
I've got I use a 3-diopter lens with a ring light. And and I've got all the suction tool to lift the chips and place them.
And presumably the limitation on at the end when you could see it was time to stop because there was the lead-free in particular was the main thing. Was it also about you could see the market disappearing at that time?
Well, that basically there were a number of things that combined. The market was falling. People wanted, quite sensibly, digital in and out, which would render complete redesign, more surface mount chips, completely different software to control those chips. I decided that really wasn't a way forward for me. And then Xilinx, the final straw, well, not the final straw, the next thing was Xilinx. stopped making the plug-in version of that chip which I use, although you can still buy them if you're lucky. But it was going to go on surface mount, again, new board. So it meant things were changing. It meant new board layouts, more complex assembly, market was dropping. Lead-free was just the final straw, but it was the excuse I gave, but there were other reasons.
So did you kind of make a last batch with all the materials you had at that point and sell them, or did you only ever make them to order as you were going along anyway?
No, they were made in batches of 100, and I sold all the last batch apart from one which I kept, which was my keep forever one. So I've now got two because I've also got this new one I built. And I've used the two together because I did some new software development for this other company who wanted their own time-based correctors. And I actually redesigned the software for the color locking and did it in a different format. So it's now done in a table. So I could actually build a unit which converted any two formats from any one format to any other without any knobs. So if you want a time-based corrector board, which does PAL to NTSC, NTSC to PAL, but does CCAM to CCAM, that could be made without any controls. But along the line, I did a few improvements, and so there are some subtle improvements in the locking capability. You mentioned the fact that it can lose lock. Yeah. I actually improved there's now you can have up to a 10-second hold on the color locking, and that was added for this company again. I actually put a longer lock on them so that if they have glitches on their tapes, then it won't lose lock. Right. So there are improvements available.
But there was no. What I'm trying to say, I think, was when you'd made that decision.
Yes.
That you were going to stop back in 2006.
Yes.
Okay, you did more later, but did you decide to build up some inventory at that point? Or was that never going to be affordable anyway?
No, there were at that point some things became unavailable anyway. In fact, the last 100 Xilinx chips, I actually had to complain to Xilinx because they had failed to notify me that they were dropping the plug-in part, and I actually had to buy them on the open market through my supplier, which cost me £1,000 more. And to be very fair, the company that, well, it was the intermediate, it wasn't Xilinx themselves, but the intermediate who should have bought through in the States. I actually talked to the MD and he paid the £1,000 that I would otherwise have lost. So very, very fair company. Mm. It never cost me any more to buy those last batch of Xilinx, but I could not have bought any more in that way. I did buy some recently.
That was the end at that point. There was no option to make an extra 500 or something. It would cost a fortune anyway.
Well, it would have been, yes, it would have been uneconomical with the falling market to do any more. But I had enough bits. Basically, I had no more bits to make a complete one at that point. But when I had to start a couple of years ago to build a few more, I had to buy some parts from China. Some parts were parts that were available in Europe, etc. And I found a very good dealer who would sell me all the bits I needed in the end. So I bought enough to build 6. But as I say, I then ran out of panels. No more panels, no more cases. None of those companies are there anymore. It would cost thousands to start tooling and everything else.
Absolutely never going to happen again. Right.
Dead end. Very sorry. Yeah. But I'm also reached 76, so I think I've had enough anyway now.
Okay. Yeah.
Yes.
So, Gordon, I really want to say thank you very much indeed for your time. It's been absolutely fascinating talking to you. There's been more to talk about, your history and everything, more than I expected, actually. It's been really good. And I hope now that people can appreciate these. And maybe we can keep some of them going for a bit longer. And I'm sure the value of these is going to probably go upwards and upwards over the following years as more archivists get more desperate, trying to find time-based correctors that are, like these, that are supportable and repairable, and we're going to keep working for a long time. So it's been fascinating talking to you. I really appreciate your time. Thank you very much indeed.
Well, thank you very much too for your interest, and thank you very much for all you've bought over the years, and obviously in promoting me in this way. And as I say, if anyone does want a software upgrade, I can now do it. I bought 100 chips last year, so I've got spares now, which I didn't have before.
Right. Oh, that's really useful. Right.
Yeah.
Thank you very much indeed. Bye for now.
Thank you. Nice to talk to you.
Bye.
Yeah. Bye then.
Well, I hope you've enjoyed having an in-depth look at the GTH Electronics ACE Timebase correctors. I'll do plenty more content on audio and video technology in the near future. Bye for now.